Welcome to session 2 of your course. The session outline is as follows. In session 2, we'll be working with the Arduino. We'll be dealing with concepts such as digital output, digital input, analog output, and analog input. So go ahead and plug your board in. We'll have some fun. Before programming, you need to remember this, right? Every time before you start programming, you need to do two things. First is to select your board, and the second is to select the serial port. For selecting the serial port, you need to open your Arduino IDE, and after you have connected the board to your computer, go to the tools option and come down to the serial port option. There you need to select the appropriate COM port number. To verify whether the COM port number is your Arduino's COM port number, you need to go to your device manager. So to do that, you need to go to my computer, right click on it, go to manage device manager and COM port option, and this is how you'll get to know to which COM port the Arduino is connected to. The selection of the board is similar. In your Arduino IDE, you need to go to the tools option and come down to the boards option and select the appropriate board that you are using. If you are using the flip baseboard, please note that you have to use the board option as Arduino Nano. I mentioned earlier that the flip baseboard is based on the Arduino Nano board. So whenever you are programming the flip baseboard, the board type you have to select as the Arduino Nano. We'll start with program number 1, that is LED blink. The aim of this program is to interface a LED to the Arduino and switch it on and off continuously. So let's get coding. LED blink is also called the hello world of physical computing. So the pseudocode is it's as follows. You have a LED, you want to turn it on, wait for some time, turn it off, wait for some time, and repeat the entire process. So this entire thing is called LED blink. It is called the hello world of physical computing because anytime we learn a new programming language, the first program that you do or the first program that you execute is the hello world program. Similarly, in the world of physical computing or in the world of electronics, LED blink is the first program you always do. So what and all will you be needing to do this experiment? You'll be needing the Arduino board, a breadboard, a few jumper cables, an LED, a 1 kilo ohm resistor, and a USB cable. The 1 kilo ohm resistor is color coded. You can see that each resistor has their own color bands, and for the 1 kilo ohm resistor the colors are brown, black, and red. So what is a LED? An LED, or also called as a light emitting diode, emits light when a small current passes through it. A LED is an electronic component that emits light whenever a small current passes through it. You can identify it as it looks like a small bulb. The picture here illustrates how a LED looks like. A LED will be having two legs. The longer leg will always be positive and the shorter leg will always be negative. Where the shorter leg is present, you can see that there's a flat surface on the LED itself, and this is the schematic symbol. Please note that the LED will work with only one direction, so if you do the connection wrongly, you might end up burning it. So what is a resistor? A resistor is another electronic component that restricts the amount of electrical current that can flow through a circuit. The color bands indicate the value of the resistor. It is easy for you to grab the wrong type, so be careful. You have to select the appropriate resistor correctly. The schematic of your circuit is as follows. The LED will be connected to some pin of the Arduino, and the positive will be connected to some pin of the Arduino, and the negative leg of the LED will be connected to a resistor, and another leg of the resistor will be connected to ground. So this is your schematic. The circuit is as follows. Connect the anode of the LED or the longer leg of the LED to pin number T3 of your flip baseboard. Okay, and the shorter leg or the cathode leg or the negative terminal of the LED is connected to ground via a resistor. Similarly, if you're using a Arduino board or Arduino compatible board, the circuit will be like this. So let us see how to build the circuit. I'll be teaching the practical examples with respect to the flip baseboard, but the same concept applies to any other Arduino or Arduino compatible board that you are using. Keep the flip baseboard and the breadboard side by side to each other. Take a jumper cable and connect the 5 volts pin to one of the power rails of the breadboard. Take a second jumper cable and connect the ground pin to another power rail of the breadboard. Make sure that the positive 5 volts and the negative ground power rails are different. Make sure the wires do not intersect each other. Next, take your LED and put it into the breadboard like this. Make sure you can differentiate the positive and negative terminal. From the positive terminal of the LED, use a jumper cable and connect it to pin D3 of the Arduino. And from the negative end of the LED, use a resistor, a 1 kilo ohm resistor, and connect it to ground like this. So this is how you rig up your circuit. Open up your Arduino IDE, and whenever you open up, a bare minimum program appears. Well, I mentioned that voids, the setup function and the loop function are the basic required functions in your program. Apart from that, it's a good programming style to always write comments, write as many comments as possible so that anyone who reads your program will be able to understand what your program does. And also, indentation is also a good programming practice. So whenever you're writing codes inside functions or inside anything, you have to make sure you maintain proper indentation. So we'll start writing the code. You load up your Arduino software and start typing like this. The first line of my code is int LED pin equals 3. LED pin is a variable, it is of type integer, and I'm equating to 3. This means I've connected a LED and I'm connected the LED to pin number 3, and I will be controlling that in the future. Next, we come to the setup function, and inside the setup function we write the pin mode. Pin mode is a function that will tell the Arduino what that particular pin is. So I do a pin mode LED pin comma output. So this tells the Arduino that pin number 3 is a output pin. I come to the loop function. Inside the loop function I write my main program, the main working of my program rather. So first I need to switch on the LED, so I do a digital write LED pin comma high. When I execute this line of code, it will send high to pin LED pin. LED pin is nothing but D3, so it will send 5 volts to D3, thereby switching on my LED. After I switch it on, I give a delay of 1000. I mentioned earlier that delay, it takes in the parameter as an integer type, and whatever number you write inside the delay represents milliseconds. So 1000 milliseconds is equivalent to 1 second delay. After I wait for 1 second, I again do a digital write LED pin comma low. So when I do this, it will send 0 volts to pin T3, thereby switching off my LED. And after I switch it off, I again call a delay 1000, wait for 1 more second. And this process repeats continuously since it's written inside the while loop. So you have two options to burn the program. First thing is to compile, and second thing is to upload. After your program is ready, what you need to do is you can compile the program by clicking on the tick button. But it is whenever the tick button is pressed, the program will be compiled. But in order to burn the program or upload the program to your Arduino, you need to press this upload button or the right arrow mark button. Again, remember, whenever you are uploading any program, it will again be recompiled, and if there are no errors present, only then will the program be uploaded. So this is my entire program. My LED is equated to 3. Then in my pin mode, I'm calling it as an output pin, and in my loop, I'm sending a high, waiting for a second, sending a low, and waiting for another second. Now please note, words or letters highlighted in red must be in capital. These are keywords. You cannot do anything else. You have to maintain the keyword standards. Starting your program. After connecting your flip baseboard or the Arduino board to your computer,
you need to go to your device manager. So I just right click on this PC or my computer, to right click and go to manage option, and there you have your device manager here. So you can just go there, and here you have your COM port or your ports, that is COM and LPT port. Just expand that and you can see that my flip baseboard is connected to COM 18 and the name is USB serial. So if you're using a Arduino board, then it will be mentioned as Arduino Uno itself and a relevant COM port number. The number assigned is dynamic and it depends from system to system, and it varies. It can vary every time you connect it. So every time you connect the board to your computer, it's always better that you first check what is the COM port number. Once you get to know what number it is, you can just remember that and close it and open your Arduino IDE. So the Arduino IDE opens up and it opens up your bare minimum program. So here I start typing my main LED blink program. We'll start with program number 1, LED blink. So I just remove the comments part. Okay, so I mentioned in the setup so before the setup you need to declare what pin the LED is connected to. So I do int LED equals 3. So there is no need for you to mention it as D3 for all digital pins. You can just mention the number. Next I come to my setup function. Inside setup I declare the pin mode of the pin. So I do a pin mode, then LED comma OUT output. So I declared that my LED pin is an output type. Next you can just come to your loop function, and here I need to switch on and switch off continuously with 1 second delay. So I'll do digital write LED comma high. So this will switch on my LED connected to pin number 3. Then I call a delay of 1 second, nothing but 1000 milliseconds. Then I again do a digital write low, digital write LED comma low. Then I again call a delay of 1000 milliseconds. So once my program is done, I need to go to tools and I need to select my board. So since I'm using the flip baseboard, I need to select Arduino Nano. If you're using any other Arduino board, you need to do the appropriate selection here. So once that is done, I can again come down to processor. It's at Mega 328, don't change that, and the port is COM18, so I select that. Okay, next you can see the button highlighting here is called verify. This is used to verify your code, and then there's a button here to upload your code. The good feature of Arduino IDE is you can just click on the upload and it will first compile the sketch, and if no errors are found in the sketch, only then it will upload to your board. So you can see now it's compiling, it's coming as compiling sketch, and once it starts uploading you can see that there are 2 LEDs on the board that will start blinking. Those are your TX RX LED, and once the upload is done it will show done uploading, and you can see here that my LED connected to pin number 3 starts blinking with 1 second delay. So this is my simple LED blink program. Suppose I need to make it blink faster, then in my code I give a less delay of, let us say 500 millisecond or maybe even 200 millisecond. So I just do that. I don't even have to save it. I can just press on the upload button. It will again recompile my sketch, and the new compiled binary file will be uploaded to my board, and you can see once it's done uploading, you can see that the blinking is faster. Same way, in the challenge I had given you that you need to blink it to mimic a heartbeat. Then you can add more statements here. So you do it's like on off. So we'll give a 1 second on and 1 second off. And what I do, I'll just repeat the statements, and I will again switch it on for 1 second and maybe switch it off for 4 seconds. So this is how I do a mimic of heartbeat. Small duration on, small duration off, small duration on, long duration off. So see, I'm uploading that program and we'll see whether it will work. Okay, so the delay is too much, so let us say I'll give a 200 and maybe 800. You see, it's mimicking a heartbeat. So this is your basic LED blink program.
A few simple challenges for you. Let's make LED on pin number 9 blink. Challenge 1A, blink the LED connected to pin number 9 with 200 milliseconds interval between the blink. Challenge 1B, blink the LED connected to pin number 9 to mimic a heartbeat. The hint is heartbeat pulse. High, low for a long duration. High, low for a long duration. So repeat this process. Let's see how we can do it. Challenge 1C, connect 3 LEDs to 3 separate IO pins and blink them simultaneously. So these are a few challenges for your program 1. Moving on to program number 2, digital input. The main aim of my program is to interface a push button switch to Arduino and control an LED based on the switch condition. So digital input requires digital sensors. Digital sensors are more straightforward than analog ones. No matter what the sensor type, there are only 2 settings, on or off. So digital sensors only give 2 outputs. It's either on or off. Signals are always either high or either low. Voltage signals for high will be little less than 5 volts and voltage signal for low will be 0 volts for most of your systems. This is what a push button is. The push button has 4 legs, 2 legs on each side of the face. The legs on the same side of the push button are not connected to each other. The legs on the opposite side of the push button are connected to each other. The figure here represents the leg connectivity. And this is the schematic of your circuit connection. The push button is connected to pin D4 and the LED is connected to pin D5 as follows. So this is how you need to rig up the circuit if you are using the Arduino Uno board. I'll teach you how to rig up the circuit if you are using the flip base board. The method is similar no matter which board you use. The method is similar, so follow this. First thing, place your board and place your Arduino board and your breadboard side by side to each other. Take a jumper cable and connect the 5 volts from the board to one of the power rails of the breadboard. Take another jumper cable and connect the ground pin to another power rail of the breadboard. Now plug in your LED. Make sure you can recognize the positive and negative of the LED. The negative of LED is grounded through a resistor, through a 1 kilo ohm resistor, and the positive of the LED is connected to pin T4 of the Arduino. Next, take a push button and place it like this on the breadboard. Make sure all the legs go properly inside the breadboard. From one leg of the push button connected to ground using a jumper cable. The other leg of the push button is connected to 5 volts using a 10 kilo ohm resistor. Please make sure it is a 10 kilo ohm resistor. And between the resistor and the push button leg, use a jumper cable and connect it to pin number D5 of the Arduino. So here we are using a resistor that is pulled up, that is connected to 5 volts. So I'll be introducing you to a new concept called pull up. So why pull up? In the code that you are about to write, we write high to the input pin. But how can we write a high to an input pin? Generally we read something, right? How can we write something to it? Well, that's an unusual aspect of the Arduino. Writing high to an input pin turns on an internal 20 kilo ohm pull up resistor. So what is a pull up resistor? For electricity to flow, you need to understand this. For electricity to flow, there has to be a complete circuit from the power to the ground. So from VCC to the ground, there must be a complete circuit if the electricity has to flow in the system. If a microcontroller pin is not connected to anything, it is said to be floating, and you can't know ahead of time what the value will be when you read it. So when the push button is just connected to the Arduino D5 pin without anything, just you're connecting that to D5 pin, when you push it, you don't know whether it was on or off previously, right? So now when we are introducing the pull up resistor, what we are doing by default, the you'll be getting 5 volts on pin D5. So D5 will always be getting 5 volts. So whenever you read D5, 5 volts will be there. And if the button is pressed, the circuit gets completed and the electricity flows from 5 volts to ground. So whenever you press the button, the circuit is completed and you'll be getting 0 volts on pin D5. So if button is not pressed, 5 volts will be there on pin D5. If the button is pressed, then 0 volts will be there on pin D5. Using this, you can get to know if a button is pressed or not. So for digital input, we'll be using the following functions. You can connect any digital input to your Arduino using pin number 2 to pin number 13. The digital input needs a pin mode command, pin mode, pin number, comma, input. Make sure you use all caps for input. To get a digital reading, you do a digital read and the pin number that you want to read from, and you generally store that value in a variable. The digital input values are only high or low. You have only two conditions, high or low. So the program logic is like this. I mentioned earlier, I'll repeat the program logic. Initially, you're sending a high logic to your input pin. So you're sending a high logic to D5. So D5 will always be held at 5 volts. Next, you will read the button state. If the button is not pressed, then the high logic remains on the pin D5. So 5 volts will be remained on pin D5. That means the button is not pressed and the LED should remain off. If the button is pressed, then the circuit gets completed and pin D5 gets low logic or 0 volts. Then you have to turn on the LED. So this is your program logic.
Okay, we'll start with program number 2, digital input. So for that, first before programming, always check whether the board is selected properly and the port is also selected properly. Now we'll first write our code. Okay, so before setup I have to do the initial declarations. I have connected my LED to pin number 4 and switch or push button to pin number 5, so I need to declare that. So I can do a constant int or int LED equals 4 and button equals 5. You can give any variable name that you want. There's no hard and fast rule that you have to follow these. They are variables, so you can give the variable name anything that you want. Alright, next in my setup function, I have to first declare whether they are input type or output type. So I do a pin mode LED comma output and pin mode button comma input. Next, what I do, I have mentioned that I will be doing a digital write high to my button so that it will be in state high. So do a digital write button comma high and similarly my LED will be initially switched off. So I do a digital write low for my LED. So those are my setup related code. So in my loop I have to write my main function. So I have to read my input. So I do a digital read button. Okay, so that is my digital read, and whatever I read I need to store it in a variable. So I call int x equals digital read button. Okay, next I have to see if my button is pressed, then I will be getting logic 0. So if I get logic 0, then I have to switch on my LED. So I write my if statement. If x equals 0, it means my button is pressed. Then I open up my curly braces to define my if loop. I do a digital write LED comma high. So I hope you understood this logic. Initially the button state will always be high, and I have done the circuit connection in such a way that if the button is pressed, then the logic changes to 0, and if I read the logic 0, I have to switch on my LED. So I come out of my if loop. So if x is 0, I have to switch on, otherwise if x equal to 1, then I have to switch off my LED. So I have to do a digital write low. Okay, so if I'm reading logic high on the pin, then my LED should be off. Okay, so this is my basic program. Here there's no need to, if else is not needed, you can do two ifs, or you can do one if and one else. It doesn't matter. So once this program is done, I just upload it. So it is compiling, the sketch is compiling, and now it's uploading. And once it's uploaded, you can see if I press on my push button, my LED becomes high. If I release it, low. So press high, release low. So this is my second program, digital input, where I will be reading the state of my button, and if the button is pressed, the LED is made to switch on, else the LED is made to switch off.
Program number 3 is called analog output. The aim of the program is to interface an LED to the Arduino and switch it on and off slowly, thereby illustrating the fading effect. So fading in, fading out, is it analog or digital? Well, fading effect is an analog function. Few pins on the Arduino allow us to modify the output to mimic an analog signal. This is done by a technique called pulse width modulation. So the mimicking of the analog signal is done by a technique called pulse width modulation. So what is a pulse width modulation? This is the concept. To create an analog signal, the microcontroller uses a technique called PWM, or pulse width modulation. This is achieved by varying the duty cycle. Whenever you vary the duty cycle, we can mimic an average analog voltage. The figure here below illustrates the pulse width modulation. Duty cycle is nothing but the distance between the on and off cycle. Whenever the distance between the on and off cycle is between two on cycles are equal, it means it is in the medium voltage range. If the distance is very low, it is around 10% duty cycle. If there is 100% distance between them, it means it's 0 volts. If there is 0% distance between them, it is 5 volts, and if there is very less distance between them, then it's 90%. So that's the relation between the distance of the pulses and the duty cycle. So I'll be introducing you to a new command. The new command is called analog write. Analog write is a Arduino function that has two parameters, the pin and the value. Pin refers to the output pin, and for analog write, the pin is limited to pins 3, 5, 6, 9, 10, and 11. These pins are denoted by the sign symbol on the board. The value is the 8-bit value that you can pass. The analog to digital converter ADC in the Arduino, we learned that it is a 10-bit ADC. So 10-bit is 10 to 1023 discrete values can be obtained. But for analog writing, we use a digital to analog converter, a DAC, and this DAC is 8-bit and not 10-bit. So 8-bit resolution is nothing but 2 power 8, that is 256 discrete values, or 0 to 255 values, where 0 is equivalent to your 0 volts and 255 is equivalent to your 5 volts. So I'll teach you how to rig up the circuit. Place your Arduino board and base breadboard side by side to each other. Take a jumper cable and connect the 5 volts of the Arduino to the power rail of the breadboard. Take another jumper cable and connect the ground pin of the Arduino to another power rail of the breadboard. Place a LED like this. Again, make sure you know the orientation of the positive and negative leg. The positive of the LED goes to pin D9 or any of the PWM pins of the Arduino. I am using pin D9 for this. And the negative of the LED is connected to ground via a 1 kilo ohm resistor. So this is your circuit. So we will look at the program. The program is already there in the examples. So you can, in your Arduino IDE, you can go to File, Examples, 01 Basics, Fade. So using this, you can open up your program. I will just discuss the program in a bit. I'll be giving you two challenges. Challenge 2 is change the rate of fading in and fading out. There are at least two different ways of doing this. Let's see if we can figure them out. Challenge 2B is to use at least two LEDs so that one fades in while the other fades out. So when one is fading in, another LED should fade out. Let's see whether you can achieve this.
Programming the baseboard with program number 3, fading. So I can access the LED fade code by going to File, Example, Basic, and Fade. Once that is open, I need to first select my board. Just verify whether the board you have selected is proper and the board that you have selected is proper. Once that is done, we'll look into the code part. So this example shows how to fade an LED on pin number 9 using the analog write function. So I've rigged up my circuit here, and this what I do, I just change the pin to pin number 9 on my Arduino board. So this is I'm basically modifying my basic LED blink circuit and connecting the LED to pin number 9. It's mentioned here that you can use any of these pins. Okay, so see, let us first discuss the program. I'm declaring a variable LED and I'm telling LED equals 9. So I've connected my LED to pin number 9. Next, I'm declaring two more variables. One is brightness. The brightness is 0 initially and the fade amount is 5. So every time I want to fade the LED at how many points I need to fade it, so they're declaring it as 5. In my setup, I'm just doing a pin mode LED, output, so I'm declaring LED as output. Now coming to the main loop of my program, I first do a analog write LED, brightness. So brightness initially is 0. So I'm doing an analog write LED, 0. So I'm sending 0 volts to my LED first. So it will be in its off position. So the initial position is off. Next, I do a brightness equals brightness plus fade amount. So fade amount I have given it as 5. So I increment the brightness value by 5. So 0 plus 5 becomes 5. And I then check if my brightness is 0, or if my brightness is 255, I need to reverse my fade amount. So initially, if my brightness is 0, then I need to make my fade amount as -5, but my brightness right now has become 0 plus 5 equals 5. So brightness is not 0 and brightness is not 255. So what it will do, it will wait for some more time and again go back to the top, and it will write the new brightness value. My new brightness value now is 5. Next again it will increment it by 5. So 5 plus 5 equals 10, and again the condition is not met. It will give a delay of 30 milliseconds and again go back and will write 10. So you see that the fading picture is coming into picture. 0 became 5, 5 became 10, 10 becomes 15, 20, 25, 30, so on and so forth till it reaches 255. So this continues. So you can see from 0 light intensity till light intensity of 255, the LED switches on. So it's your dimming effect or your fading effect. So once my brightness becomes 255, so it's like 250 plus 5 equals 255, it will come to this condition. So it will check whether brightness is 0, no, or whether brightness is 255. Yes, the brightness has become 255. Then I do my fade amount as minus fade amount. So fade amount, that is 5, becomes -5. It will come back on top and it will write 255, and then what it does, brightness plus fade amount is -5. So 255 plus -5 equals 250. So you reach from 0 to 255, and again from 255 you're going back to 0. So 255, 250, 245, 240, all the way down to 0. Again if it comes down to 0, the fade amount that has become -5 will again become minus of -5, so +5. So again fade amount becomes +5 and the whole cycle continues. I hope you have understood the logic of this program. So I just upload this program and you can see for yourself how the output works. My sketch is compiling. Since this program is a little bigger, it takes a little more time to compile and upload. Once uploading, you can see there, see how my LED fades from 0 all the way to full bright, then again come back to less. And this is because the delay is 30 seconds. Suppose I give 30 milliseconds. Suppose I give it as 100 milliseconds and I upload it. You can also press Ctrl U button to upload it, and does the same thing. Now you can see the difference. With more delay, the delay is more, so the amount is more. Same way the fade amount also can be changed. So if you want 1, and I'll give a delay of maybe 20 milliseconds and I upload this. 1 means it takes a lot of time, and yeah, not much of a change will be detected, but yeah, you can see the change for yourself. After some point, detecting the intensity, your eye fails to detect the intensity, but yeah, see, so this is how you do a LED fade.
So program number 3 is called analog input. The main aim of my program is to interface a LDR sensor or a light intensity sensor and control an LED's intensity depending on the readings of LDR. So LDR is a type of analog sensors. You have different types of analog sensors. Some examples are your mic, photoresistor, potentiometer, temperature sensor, accelerometer, etc. The variables, a mic has a sound variable, a photoresistor has a light variable, so the light level. Same way accelerometer has a variable in your tilt XYZ axis. So these are some common examples of your analog sensors. In this circuit, you will be using a photoresistor which changes resistance based on how much light the sensor receives. There is one disadvantage of any microcontroller. and Arduino is no such exception. An Arduino cannot directly interpret resistance, so it cannot directly read what change in resistance is. Any microcontroller only has the ability to read voltages. So we need to use a voltage divider circuit with a photoresistor to detect the change in voltage. So a voltage divider circuit is an electronic circuit where whenever resistance of one component changes, the change in resistance gives a change in voltage. So that change in voltage is measured by the Arduino, and that is mapped to your light intensity level. So you can just look into voltage divider. It's a very awesome concept in electronics, and you will have a better understanding of this. The voltage divider will output a high voltage when it is getting a lot of light, and it will output a low voltage when there is little or no light present. So this is how your voltage divider with your photoresistor works. The circuit is as follows. You can one end of the photoresistor is directly connected to 5 volts. Other end is connected to the ground through a 10 kilo ohm resistor. Please note, you have to use a 10 kilo ohm resistor here. Between the 10 kilo ohm resistor and the photo leg, you connect a jumper cable to pin A0. Since this is an analog sensor and you're doing an analog read, then you have to use any of the analog input pins only. Next, the positive of the LED is connected to pin number 9. It has to be a pulse width modulation pin. And the negative of the LED is connected to the ground through a 10 kilo ohm or a 1 kilo ohm resistor. It doesn't matter. So the rigging of the circuit is as follows. Keep your Arduino board and your breadboard next to each other. Take a jumper cable and connect the 5 volts pin to the power rail. Take another jumper cable, connect the ground pin to another power rail of the breadboard. Next, place a LED on the breadboard and connect the negative of the LED to the ground using a 1 kilo ohm or 10 kilo ohm resistor. The positive of the LED goes to pin D9. Here we have to use any of the pulse width modulation pins. I am using pin D9. Next, place a light dependent resistor or a light intensity sensor like this on the breadboard. One leg of the LDR is connected directly to 5 volts. The other leg of the LDR is connected to the ground through a 10 kilo ohm resistor. It has to be a 10 kilo ohm resistor. Please remember this. And between the resistor and the light intensity sensor, take a jumper cable and connect it to A0 or A1 or any of the analog input pins. Okay, the code is as follows. I am declaring a sensor pin variable called sensor pin, and I am equating it to A0. So in Arduino, whenever you have to mention what for analog pins, you have to prefix it with A. For digital pins, there's no need for you to prefix with the D, but for analog pins, you have to prefix it with A. So A0 is analog pin 0. Next, I am declaring another variable called LED pin, and I am equating it to pin 9. And the light level is a variable where I'll be storing my light intensity values. Inside my setup, I declare my pins as output and input using the pin mode function. In the void loop, I first do an analog read of my sensor pin. So whatever sensor data I am reading, I'm storing it to a variable called light level. Next, I'm calling a function called auto-tune. Auto-tune is my function that I have defined. This function I have defined at the end of the program. So let's look at what auto-tune function does. I mentioned earlier that the aim of my program is to read my light intensity sensor value, and whatever I'm reading, the same thing should be sent to my LED. So if there is a very high intensity light falling on the LDR, then the LED should glow very brightly. If there is no light falling on my LDR, then the LED should be switched off. So this map, you have to map the light intensity sensor to the LED. But we mentioned earlier that the analog input is it has a 10-bit ADC but only 8-bit DAC. So because of this change of resolution between your ADC and DAC, you cannot just write whatever values you're getting from the light intensity sensor to your LED. The light intensity sensor output gives discrete levels of 0 to 1024, but the light LED can handle only levels of 0 to 255. So we need to map this. This mapping is done using a function called map function, and this mapping is done inside the autotune function. So inside the autotune, I first declare I call my map function. Map function takes in five inputs. The the particular variable you want to do operation on, what is the lower limit of that, what is the upper limit of that, what is the new lower limit of it, and what is the new upper limit of it. After mapping, the output will be mapped between 0 to 255. Whatever is the input will be mapped between 0 to 255. And then I'm calling a constraint function. We'll discuss what these functions are in the next slide. So after I do all this, I come out of my autotune loop, and whatever is the new light level, I just do an analog write to my LED pin. So whatever I read, I am doing a autotune. I'm just manipulating the red values, and the new value I am writing it to my LED pin. So this is my basic code of my light intensity sensor. So the map function has these parameters. It has a value from low, from high, to low, to high. Value is the parameter you want to map. From low is the lower bound of the value's current range. From high is the upper bound of the value's current range. Too low is the lower bound of the value's target range or the new range, and too high is the upper bound of the value's target range. I mentioned earlier, explanation is here. We've read that analog read is from 0 to 1023, but analog write is only from 0 to 255. So we can squeeze the large range to a smaller range using the map function. Constraint function takes in three parameters: the number to constrain, the lower end, and the upper end. Because the map function can still return a number outside the to and from range, we need to call a function called constraint that will clip the numbers into the range. So even if you get numbers from after the map, even if the output is more than 0, more than this 1024 or this thing, you can clip those numbers accordingly using the constraint function.
Now do program number 4. Program number 4. That is your simple analog in. That's your analog input. So I will open a new this thing and I'll start typing the program. You can always access the programs from the download section that I mentioned earlier. So here again I have to first do my declarations before my setup. So what are the declarations? The declarations are for my LDR and my LED. So I do a int LDR equals A0 because I've connected my LDR or my light intensity sensor to analog pin 0. Next I do a int LED equals 9. I've connected my LED to the pulse width modulation pin number 9. Now in my setup function I will do the necessary setup coding. So first is my pin mode, LED as output, and pin mode LDR as input, and initially LED is off. Okay, so these are my basic setup related codes. Next, coming to my loop function. So inside my loop I write my main code. First thing I need to do is I need to read my sensor value. So I do a analog read LDR. So this thing, whatever I read, I will store it in a variable. Let us say X, and this I'll mention it earlier as int X. Okay. Next I need to call my autotune function. as auto tune with T capital. Okay, next I declare my function void auto tune, and then I define my function here. First thing I need to map it, so x equals map x comma 0 comma 1024. So from 0 to 1024 I need to map it to 0 to 255. So first thing I do is I map my light intensity value between 0 and 255. Okay, then I do a constraint x comma 0 comma 255. So I make sure x doesn't exceed the values 0 and 255. It doesn't go less than 0 and more than 255. Okay, so once my auto tune function is defined, I just do a digital write, not even a digital write, analog write LED comma x. So whatever is the manipulated sensor value, I will be writing it to my LED. So this code I will now upload. Okay, the sketch is compiling and it is uploading now. So it's done uploading room lights and then partial darkness. I'm conducting this video so I can give you a cool demonstration. So this is where my light intensity sensor is, and this is my LED. So what is happening when I'm blocking the light intensity sensor with my hand, with my finger, it's not getting any light, and the same thing is being reflected here on the LED. It's glowing. Now I remove it, it's glowing a little more. I just block it with the paper so that it's visible to you even more. Now I use my torch, and you can see that as I put more light here, the intensity, LED's intensity becomes more. So this is like how much ever intensity of light is falling on the sensor, the same amount is being displayed by the LED. Yeah, you can see that, right? So now suppose I want to do the reverse operation, something like a smart automated lighting system, where when the sun comes up the light switches off, and when the sun goes down the light switches on. So for that, what I have to do is I just have to change my map function. So whatever from 0 to 1024, I'm mapping it to 0 to 255. I just do the reverse of it. 0 to 1024 is mapped to 255, 0. So the highest value is mapped to the lowest value is mapped to the highest value, and the highest value is mapped to the lowest value. So this will give me the reverse operation. Now I will upload this code. It is uploading, and now once it's uploaded, you can see that when there is no light, my LED is more bright, and when I'm giving some sort of light to this, see, when I start giving light to this, my LED becomes less, and when I give high amount of light, it becomes almost 0. So when there is no light, very bright. When there is high light, it becomes almost 0. So this is an application of something like your smart lighting system using Arduino.
So I have a challenge for you, challenge 3A. Connect 3 LEDs to 3 pins of the Arduino and a LDR as an input sensor. Now if the light intensity is between 0 to 300, then only LED 1 should be turned on. If the light intensity is between 301 to 600, then LED 1 and LED 2 needs to be turned on. And if the light intensity is greater than 600, then all 3 LEDs must be turned on. The hint is as follows: you need to read the sensor value And according to the given conditions, use a digital write LED, high to switch on the respective LEDs.